Internet. We're back again, finally, after many weeks of hiatus. We're back to do some more electronics. Welcome back to the build stream, everyone. Woo! So, actually, I'm super excited today because we've got some cool stuff to show you.
You probably want to face your camera.
Yes. I actually have something fantastic. This is kind of really cool. It's a sensor kit. In fact, I just had a birthday recently. I turned 28. My buddy Alan, who's right here, got me this awesome sensor kit. I'm actually so excited to check this out. And what we were thinking about tonight is that what we're going to do with the sensor kit is we're going to do like a random grab bag. So we're just going to like open it up, and we're going to reach inside and grab a random thing. And that's what we're going to try and mess with tonight. And I think that sounds like a fantastic idea. And
then we'll see what we can do with it and show what you can do with it.
let's see what can happen, okay? So I'm going to dump them. Oh, I'm just going to reach. Oh God. It fell out everywhere.
No, still on the table.
Okay, wait.
So, okay.
I'm going to grab one.
Take it out. Mix it up.
Okay, here we go. This
Okay,
one.
and let's see what this one is. And it is...
It is a... Whoa!
What is it? Death Ray?
It's man, I'm stunned because this is a magnetic hall sensor. That's going to be pretty exciting, I think. Holy moly, this is going to be crazy. So, from what I understand with a hall sensor is that it detects a magnetic field, and then from the north and like south magnetic fields, it determines an orientation. Right?
It actually doesn't quite. Well, it kind of does. Kind of. It is. What is it? It determines the strength of a magnetic field close by.
Oh, really?
Yeah. The Hall effect, what it is that whenever you have electrons moving along, if there's a magnetic field, it causes those moving electrons to go one way or the other. So, so it kind of makes it spin, so to speak. But it's actually kind of clever effect because if you have magnetic field coming in through this stream of electrons, more electrons maybe might go this way, depending on the direction of the magnetic field. And what happens, just a clever thing about the Hall effect, is that there's more electrons on this side of material compared to this side. Hey, there's a voltage across it. And that's how the Hall effect works. So whenever a magnetic field encounters a moving current, it makes one side of material more positive than the other, and detect the voltage, and therefore detect strength of the magnetic field. So that's what Hall effect essentially does.
Oh, that's neat. I didn't know that.
Yeah. So they use it in all sorts of stuff. So what happens is that some keyboards, high-end keyboards, not this one, instead of actually using actual contact and stuff, there's no magnet inside. And the Hall effect sensor detects whether the magnet comes down or not. It detects whether magnetic fields triggered it.
Really?
There's various other kind of effects as well too. For example, you can put it other kinds of sensors that you need a magnetic field to trigger something. Lots of times, you can actually use Hall effect sensor for touchless switches. You want to guarantee that something triggers a switch, but you want to have a totally solid state. You can't have anything optical, but you just have a magnet on one side, a Hall effect sensor on the other one, and you can actually detect whether a switch or some door or open or close. And it's highly sensitive, and it's fairly robust to noise, which is why they use.
That's neat. So, can we just test it with any kind of magnet?
We should be able to, yeah.
Neat.
Yeah.
Okay, so let's try and hook it up.
Okay, so what it is, I probably want to look up the documentation on this. So this kit we have is from Knight's from.
Well, I know one thing for certain. Yes, let's talk about the sensor kit before we continue on. So this is the Key Studio 37-in-1 sensor kit, and this is the upgraded version. So the version 3.0. Man, this is crazy. It's got 37 different sensors in it.
So we let people see inside it. So it's just essentially more or less just filled with stuff.
Yeah, there's a whole bunch of bags of sensors in here, and like I actually went through the trouble of labeling each of them, so you can see that there's all individually labeled. I don't know if you guys can read that at all. It says infrared obstacle avoidance. I can't read it there either.
Yeah, they all know.
There it goes.
You have to pull it down a bit.
But this one's probably easier to read. But I actually labeled them because there's so many cool sensors in here, and it's important to know what you got, right?
Yeah. So if you're a beginner in terms of making stuff, this nice place to start with. If you don't want to do everything from scratch, you can actually get a kit like this for about $50-ish or so, and then it gives you all these sensors. There's all these tutorials online you can actually look up and just try stuff out, just mess around with things.
Yeah, this is super neat, and yeah, let's have some fun.
Okay, so in this case,
we got the Hall sensor, and I'm going to take a look on this little pamphlet that's in here. I've actually been reading up on it. It has a QR code that I can use to get to where I need to go. So give me a second. Anyway, you going to use your phone?
Yeah, I'll use my phone. So let's open up browser, address bar.
Are you using? Can you scan the QR code?
Yeah. So it gets that code.
Sure. Well, let's go to the wiki.
So oh, there we go.
I have to bring it in a little closer.
On that, get the 12 focus. Here we go.
Whoa!
Right? Wow.
Now,
Okay.
QR codes are still kind of magical to me.
It's up. Oh, there we go. Now we have the sensor kit.
There we go.
So, unfortunately you can't see it very well. Just go into the wiki. So, project here. So let's see if we can find
Well, I know one thing. I can see here on the 3 outputs that are on this
Hall Magnetic, Project 12.
that there is one that says S, one that says V, and then one that says G. And there's like 3 pins there. I don't know. The 3 pins. I can barely show it because it's really blurry. But there's 3 pins that comes off the end there. And off those 3 pins, one of them says S, one says V, and one says G. So I can safely assume that V is voltage, G is ground, and S would be signal. So the signal is going to be a variable voltage.
Here we are. We have the project, the Hall Effect Magnetic. So on this kit, well, it's not visible right now, so I guess we'll come back to it later. But in this case, we do have a tutorial about how to use this. So we need a...
Well, we're going to read it.
Sure.
Okay. Introduction. This is the magnetic induction sensor. See, I had no idea. It can sense the magnetic materials within a detection range up to 3 centimeters. The detection range and the strength of magnetic field are proportional. The output is digital on/off. This sensor uses the SFE read switch, magnetic field sensor. Specification: sensing magnetic materials. Detection range up to 3 centimeters. So the one thing we were saying before is that, we can use a magnet for it. It actually doesn't need to be a magnet. It can just be any magnetic material, that's pretty neat. Detection range up to 3 centimeters. Output digital on/off. Size 30 by 20 millimeters. Weight 3 grams. So here, first you need to prepare the following parts before connection. Uno board. We don't have an Uno. We have board. We have a Demilanov. This is just because we're old school. Hall sensor. Yep, got our Hall sensor right there. Let's put it down so that people can see it.
Things out of the way.
So maybe we can move this up a little bit.
That's
Shoot. That's fine. Yeah, that's good. Perfect. I'll just put them right here.
Lower it. Let's just lower it down. Get even closer if we can.
There you go. Now you can really see the grime in my keyboard.
There we go.
There we go.
Mm-hmm.
So we've got the. Let's move over here so they can see. So now what we also need is a USB cable, which is already plugged in. So you guys see here. In fact, I'm going to unplug that until we're ready to use the Arduino. And then we need some jumper cables, which I have this big old case here. And if you're doing electronics, you're definitely going to want to get a big old case like this full of jumper cables, because not having jumper cables when you want to do a project really sucks. The other thing that I did was I 3D printed these little racks. And the racks actually hold the jumper cables. And this one's not well utilized. Maybe this one's better utilized. But the only thing that's a little annoying is that you kind of have to print the racks to the length of the jumpers. So, but anyways, yeah, racks are really helpful. But if you have one of these, Yeah, you can buy your jumper cables in like ribbons like this, and you pretty much just strip them off when you need them. So in this case, we have male pins coming off the end of the Hall sensor, and we need male pins on the other side. So we need a female to male. So not these guys. These guys here. Yeah, that's another one, is that the racks also have the type of jumper they are. So this one's a female to male rack. So I'm going to take 3 of these. Although these are not very nice colors. No, those are not very nice colors at all. Maybe I'll use the gray one for the signal wire. I like to use white or gray wires for signal wires. And I like to use red and black for ground and power. Or power and ground. Here we go. The male to female, female to male. Here we go. You can also use yellow for voltage. That seems fine. And I'll use blue for ground. So now I've got my 3 colors here. And the color is actually quite important because it helps you differentiate which of these is which. So you guys can tell that one in the middle, this gray one, is obviously the signal wire. Because normally the darker color is the ground and the lighter color over here is the voltage, right? But I think that it's probably normal that most systems use white as signal, right?
It depends. Again, I think actually it depends what.
In a USB cable, it's like green and yellow,
yeah.
right? So I guess it depends on the system. It depends on also the type of the type of.
Yeah, unfortunately, the standards are kind of loose.
Because everybody does their own thing, right? Because you can kind of do whatever. I know that, like, depending on where you are in the world. They have all sorts of different communication systems. I think that the typical common ones are
red and black, typically for I guess voltage and ground, typically.
Yeah.
But then you do have, I guess,
I2C.
Yeah.
You have like I2C, and you have like SPI, right? And there's a couple other control systems that have like their own kind of color scheme. That's their specific their color. But generally speaking, you'll find like red for power, and black or blue for ground. But anyways, here, now we have our thing wired up, and now I'm going to take this end and we're going to plug it into the Arduino.
So according to
the website, anyways.
Yeah.
So
we can get the website up on the screen, perhaps, or should we?
For them to see it?
Yeah.
Well, we can just read what it says.
Okay.
It says, connect the S pin of the module to digital 3 of Uno board. Okay, so the signal goes to digital pin 3. Like that.
And so we want...
The other side just goes to ground and 5 volt, right?
Yeah.
Is it 5 volt or 3.3?
I believe it's 5 volts. Yeah, they want 5 volts.
Okay. So now, one thing that's really important here is make sure that your pins are actually lined up with the hole. It's really easy to accidentally put it in the hole beside it. But now that it's all wired up, this should be ready to go.
And now to code, now the next aspect to Arduino is that you have to tell your computer how to handle this. We have to do some coding now.
Yes, so now we're going to switch to a different type of setup for coding. Twitch Arduino programming?
Yeah, let's just go to that one.
Oh god. We disappeared.
I think that assumes a whole different type of scheme, I think.
Give me a second. I'll add us back in. Also, this is Arduino, by the way. Okay, video capture device. We want webcam 2. There we go. Now we're back. Hello there. Hello, peoples. I guess we'll make this one a little smaller, the webcam. Let's make it like that smaller. That's pretty good. I'm making an overlay on the fly, guys. Bear with me. Okay, so now what we're going to do is we're going to add the Arduinos.
What browser? Or Arduino?
Arduino. So we're going to make a new sketch, and I guess we should open up that. What is the website?
Oh, okay. So going to it's wiki.keystudio.com, I believe.
So I'm gonna change our overlay because we're not doing the stream deck right now. Still says we're doing the stream deck. Guys, give me a break. It's been a long time since I did this. That's okay. No one's in the chat, so we can't we can't be blamed. We can't be blamed for the quality of the stream. Just chatting, a programming overlay. Here we go. Edit. I really like these overlays. I can say the stuff I want to say, but I also need to change it every time. Thursday night build stream deck. No, we're doing sensors. What was this thing actually called?
Oh, okay.
Playing with Key Studio, playing with
Arduino sensors.
Key Studio?
Key Studio, Arduino.
Key Studio, Arduino sensors.
Yeah.
That's okay, right?
That should be good.
There we go. Cool. So, what are we going to do with this bad boy? Well, now we have it all plugged in. We can test for
we have to get a code now.
Magnetic materials.
Yep.
We'll also need something to test as a magnetic material. So, do we have anything? I have an idea. I know these things are magnetic because they're always getting stuck together by magnets. So I'm going to use this little coin battery here as my magnetic material when it's time to come test it. Now, we just need to go to our Arduinos, which I realize is actually in a poor place because oh god, oh no, we just want to move that down. There we go. Okay, and yeah, we gotta go find the code from the website now. I guess we should add our face cams back in. Or should we?
Yeah.
No, we're just gonna be hands, I guess.
Yeah.
You guys don't care if we're hands right now, do you? One thing I do notice is that it's a little bit quiet. I'm gonna turn up the mic a bit, I guess. Should I move the mic over here, maybe?
Yeah, that's a little bit far. Really good.
There we go. That's probably a lot better.
That's much better.
Yeah, that's 1,000 times better. Okay, so now we're back here. And we're going to go to the Key Studio thingy. Key Studio 37 in 1 sensor kit.
There's a wiki.
Is it this one? Wiki.
Yep.
Arduino.
And number 12, no.
Nope, not
that one. Looks like it's slightly different.
Is this a slightly different one? Did I go to the wrong one? Wiki.keystudio?
Actually, a multiple kit. This one is the third one upgraded.
Version 3.0.
Oh, yeah.
3.0.
And yeah, there we go.
Yes. Hall magnetic sensor.
So you should share this with people, or we'll just copy and paste the code in here.
Yeah.
Yeah. There we go.
Here we go. So we can actually read and tell what this code is going to do before we even do anything with it. But it just sets the LED pin to pin 13.
Oh, we're not. We should paste it into ID, but I don't think they see it.
There we go.
Yeah.
Let's save it too.
Yeah.
This is
there.
Okay. Saved. So we can see that the first one, the LED pin here, gets set to the pin 13. So there is actually a numeric value for each pin on the Arduino. So each of these pins that are along this side, they all correspond to a number. And when we're setting each of these pins to a variable name, that's just for us humans to understand, because our feeble human brains can't understand so many numbers and just be like, oh, 13 is equal to 14. No, that means that the LED pin should turn on, right? So we actually assign pin 13 to the LED pin, making
give it a variable name so it's easy for us to know what it is.
Yeah, it makes sense to us humans. And then this input pin is going to be pin 13. This is connect sensor to input pin 3. So as I understand about sensors is that this signal wire that comes out of here is a variable voltage, usually.
But it looks like they've decoded to threshold it, so it's either on or off.
So it's on or off. Yeah. But most of the time, if you have some sort of like a temperature sensor or something like that, this variable voltage would then correspond to whatever temperature. But in this case, it's just an on or off. This value down here, this variable 0, is variable for reading the pin status. Okay, so why do we use the pin 0?
I think they're just saving that. It's not pin 0. It's actually just saving it. So how it looks like they're working is that they're saving the value and then they're testing it after. Going to the loop code.
Okay, so we keep going down. So setup, output. Okay, so the difference between outputs and inputs is really simple, is that the inputs actually have a pull-up resistor, which allows you to do certain things with that pin without blowing it up. So it's supposed to take a voltage in. That's why it's an input. Outputs output a voltage from the outputs, but they don't have a whole lot of current. So there's only so many things that you can really drive with that output. Maybe like an LED or something. One LED. Okay, so we're going to go to the loop. And this value gets set to digital read. So digital read gives us some sort of value by reading a certain pin. So we're reading the input pin. So why are we reading the input pin? We're getting value equals the digital read input pin.
They're using a temporary variable to save it. And then they're processing it after. So the first is to get the value. Well, I guess they may have another project later, because it actually makes it useful, because rather than testing and executing right away, which you could do, it just gives you the ability to kind of delay doing your process.
I'm going to add the droid cam back in so you guys can see my kind of confused face right now. But why? Yeah, so there we go. Actually, this is a pretty good setup. Like this. Y'all can see my face now. You can see Alan over there too. So, but why?
Okay, well, in terms of programming, right now your cursor's highlighted on the val equals digital read input pin. Sometimes you want to delay doing something until later on. You just want to get the input, and that's why they're saving in the variable first. And then they can analyze and do stuff like, for example, if you recall when we did, well, this is another thing that you don't know, but a while back we worked on a debouncing input,
yes.
push buttons. But of course we couldn't detect the button right away and do something about it, because otherwise it would be oscillating. So we saved it and analyzed, did it stay down long enough before we did something about it?
Yeah,
so,
I remember that.
Yeah, so it's kind of similar in this case. Sometimes you don't want to act right away on something. You want to record it. And then when you have other things happening, you want to altogether figure things out at that point. And that's why they're saving whether the call sensor gets triggered in a variable, and then they determine what to do after, which is kind of a good thing. You want to separate your concerns. Get information, then do the action.
Okay. I'm just still wondering why they're reading pin 0.
Okay, that's what we configured. No, we're actually not reading pin 0, the value that we're saving.
Okay, so int val is equals 0. Variable for reading the pin status.
Yeah.
Val equals to digital read input pin. Okay, so now it's reading the status on input pin 3.
Yeah, and then it's storing
that makes sense.
val.
So then the val goes there.
Yeah.
So we're actually setting the val to 0 first. So it's only reading...
Initializing
it.
That we don't have a false value when you first plug it in.
Okay, that makes sense. Okay, the next one is val. If val does equal to high, so if value is triggered, then digital write LED pin low. So the LED pin is just the built-in pin. We can even change that pin 13 to digital built-in. LED underscore built-in. But let's see here. So we just set the LED. So that's pretty simple, actually.
It is pretty simple. Yeah. So we just need a magnet. Hopefully this will trigger
I'm hoping that this little coin battery here will just trigger it. Should we just try and upload it now?
Yeah, upload it.
Okay, here we go.
So you plug in your Arduino. Make sure it's the right kind and the.
Let's just double check so y'all can see what I'm doing here. So all I did was plug this bad boy in, and now I'm going to upload from Arduino. Upload. Press the upload button, and y'all can see it uploading. Now the loading bar is loading.
But
an error occurred. Says Sir open can't open device COM6. Yeah, so we must have chosen the wrong board, obviously. So Demilanov.
Yeah.
That's the old crappy board that we're using.
COM port 1 actually is still using COM port 6.
Okay.
Yeah.
COM port 1.
Yeah.
So you guys actually can't see what we're doing, but we're actually going up into tools, and we're changing stuff around. We would have to use a screen capture. Should we use a screen capture instead?
Maybe, or I know there's actually an online programming environment now for Arduino as well too, which I think because of web-based it will show up.
Oh, okay.
So
whatever, this is fine. You guys just know that we just uploaded to the wrong freaking device. Upload.
And compiling now, or recompiling, and uploading now. It's successful. Upload.
I guess we'll have to open the serial monitor. Oh, no, we don't.
No,
we actually have the light, right?
Okay, but we need a sensor now. We need a magnet.
No, it said that it can use magnetic material, so I'm hoping that this coin battery here will hopefully trigger it, because this coin battery is magnetic. If it eventually finishes uploading.
Something happening?
I have no idea.
Should finish uploading by now. It's because it's only 900 bytes.
Should I upload again?
Let's go down the bottom. Let's see if there's an error message on the bottom.
Nope, it still says uploading. So let's just disconnect this. Oh dear. Close Arduino. Open Arduino again. Plug it back in. Check the COM ports. Attempt to upload. Come on. Jack in Mega Man. Oh, hi Safara. Safara says hi. That's awesome. Magro's so cool sending you to me.
Gifted you a subscription to his channel for your birthday, which is probably almost up now.
What? Oh no, you're right. Oh, Raiden. Raiden's over there. Can you see him in the background?
Let's get him around. Let's put him in the show.
How are you doing tonight?
So, there he is.
Here's Mr. Kitty. Boop his snoot for me. Boop. Oh. You moved him at the same time I booped him. Boop. Boop. I did like 2 or 3 boops there. Oh, that's awesome. If you're gonna do if you do a Warzone, that's awesome. He'll totally bite me. Yeah, he will totally bite me. This cat, he likes having his boop snooted. So.
He likes having his boop snooted.
Okay, so I think I might know what's happening is because we may need to open the firewall.
Oh yes.
Yeah. So I think you are you on private I guess network or a public network? So you configured it as a public network.
Not sure.
Okay, so go to your network. Nope, I'm private, so that's fine. But I noticed when we started Arduino and asked whether you want to allow it on a private network. I think you might have said no and just only said a public.
Oh yeah, so how do we do that? Oh, the problem uploading the board. Here we go.
Yeah.
STK. Okay, we're gonna have to make this part a little bigger.
Not responding.
Oh, what are we building tonight? Okay, so I recently just had a birthday, and I got a present from my buddy Alan. He got me this sensor kit, which is super sweet. It's got all sorts of cool electronical sensors and little toys and bits and stuff like that to program with. And for example, there's this thing. I'm just gonna grab the first thing that's on top that I have here. This is an infrared obstacle avoidance sensor. So this is kind of cool. This is gonna be, we could use it for making like a little car or something like that. The sensor that we're playing with tonight is.
Got the bag still?
Oh yeah, like a Roomba. Kind of like a Roomba. You could totally make a little Roomba with that.
There it is. This is a non-visible. This is a Hall effect sensor, which detects magnetic fields. It's essentially a switch that gets triggered by any magnetic field close by.
Yes. So this thing down here is actually the sensor itself, and we're gonna test that guy out, and hopefully, if it working properly, it will be able to read some magnetic stuff. Safara says to make a vacuum robot. We should totally make a vacuum.
Yep,
we should do that.
That would be practical as well too.
Trying to make our own little Roomba. Oh, that's funny. Mm-hmm. But here it says AVR dude.
Okay. Programmer
is not responding. Why is it trying to use a programmer?
That is. Oh, maybe. Let's go to. Nope. It shouldn't really matter.
I see. It should be 168. Mm-hmm. I was trying to upload to a 328p.
Yeah, so that's a
this
mega.
Is a 168.
Yeah.
Okay. Make a vacuum robot to clean up the cat hair. That would actually be really good, considering that almost everything gets covered in cat hair. Is there a lot of cat hair in the frame right now? Are we cat haired on? How hairy is it? Let us know. Okay, good. This is one of the rare instances where I'm not covered in cat hair. Oh, it was done compiling. It's done compiling.
I don't think it uploaded.
I think it did.
Okay, did upload.
It says done compiling.
Mm-hmm.
Are you sneezing? Yes, I am. I took a little bit of antihistamines earlier, so I'm lucky now. But, so you're probably not... There's cat hair everywhere in the air. Like, it's everywhere. I just saw some fly up. Cat hair, man. It's not good for my allergies. Okay, so we're going to open the serial monitor. And I guess we should also open the serial monitor on
we're
here.
Not going to see an activity because we're not using it. So let's go back to Arduino environment. Let's actually...
I was going to add the serial monitor in here so we can take a look at the serial monitor. Arduino console. Is that that did not show up? Oh, this should be window. Nope. Calculate. Nope. Huh.
Is it still open, or did you close it?
I think that's still open.
Oh, okay.
Should be COM1, right?
Yeah.
So I gotta open up a new window.
One of the issues is that the Arduino IDE is written in Java, I believe, which is why it has some trouble showing up sometimes in Windows, just because it's often its own little environment and world.
I remember there was a way to get it to show up before. Let's do let's call it Arduino Console 2. Arduino Console 2. And we'll make it set to...
No, it's still not showing. Yeah.
Why isn't it showing up?
It's one of those things that Java stuff, it doesn't...
It's so weird.
It doesn't act like a regular Windows program. It just kind of...
But I'm just trying to show that that it's the sensor is working. Maybe we'll just do a display capture. Should we do a display capture instead? Okay, y'all are gonna see my computer for computer stuff. Here we go. Display capture. Windows desktop. Here we go. Oh God! Oh!
Turn it off.
Turn it off. Turn it off. Okay, so let's open up this thing and that thing. And yeah, we're gonna have to open up the stream on like something else. Could you mind open up on your tablet? Thank you. Okay, so now we're in the COM. Oh, we don't need the serial monitor, do we? Man, why did I do all this then?
Yeah. So.
Oh my God.
Yeah.
I'm adult. Okay, what am I programming it to do? Right now, we're just trying to see if it works. So,
I think you hit compile, but you didn't actually hit the upload, maybe.
Really? Oh, yeah. Okay, let's try here.
Because it's two separate.
Upload.
Yeah.
Final sketch uploading. Oh, there we go.
Okay.
Yeah, maybe I did. Maybe I accidentally hit the check mark. Okay, so what am I programming it to? What it should already do with the code that was provided is make a light that's on this board blink on and off when the Hall sensor detects something magnetic. So you know what the cool thing is, that if we can get this Hall sensor working well enough, or like working good, we might be able to like imagine like if we could run this off of like a PK ring or something like that, right? We could use it for like magic purposes and stuff. Yeah, it's a magnetic sensor. So inside of this little here, I'll bring it up close so you can see it. Inside the end of that little black thing, at the top there, that is like a little magnetic sensor, and like at the top there, that is like a little magnetic sensor. I bet you could operate it with a PK ring or something like that for sure. But let's see if one of these, you see this little, there's one light that's already on here. We're gonna see if another light turns on when I touch something to this. So it should.
But it hadn't uploaded.
Oh, it still hasn't uploaded yet, huh?
I think it's an issue with the firewall. So we have to go into your.
Oh yeah, the echo was going on because we were streaming it on another one, and unfortunately the audio doubled up for a moment. But it still seems to be uploading.
No, it should have done because it's only 900 bytes. It should have done by now. But I think it's being blocked by the firewall. That's what I've encountered in the past. So you have to go to your settings. Okay. And then you have to go to the firewall and then allow it to go through the private network.
Problem uploading the board.
Yeah, but it's Windows protecting you.
Okay.
Yeah, because it doesn't want to expose trading information that you.
Why is it protecting me? Windows, stop protecting me. Okay, so let's go unprotect yourself.
Yeah, so we have to go to, I believe, network or firewall or something. Actually, no, I think we have to go to security.
Here, I'm going to swap to the Windows desktop so y'all can see the madness that I'm going through right now.
So actually, it's in security because you have to go to firewall settings. So hit home.
Hopefully, we don't reveal any super.
Actually, Windows firewall is the bottom.
Will we reveal any information by showing them this?
Yeah, okay, yeah. So you have to go allow an app to the firewall. So down, right there.
Allow an app to the firewall.
Yeah. So Arduino.
Oh God, maybe this is probably not good information to share.
No.
You know what? We'll go back to how we had it before. Okay, we're doing some sensitive internet things.
Yeah, go down to Windows Firewall. Oh yeah, here we are. I have to find Arduino, or it might be Java.
Arduino?
Yeah, if it's not there, it'll be under Java instead.
It's like 50 Dota ones. Why does Dota need 20 of them?
Yeah, so go to Java.
Okay, Java.
Yeah. And, okay, there we go. We want to actually allow it. Oh, that's
public.
Private. Okay, so no.
This one's not though.
Okay.
Public, right?
Yeah, public.
Chain settings. Ah. Here we go. Is that okay now?
Trying to find Arduino. You should be able to hopefully find it. To install it separately. So no, it's up there.
What the heck?
You right click on the Arduino icon. Just want to see where the program is.
Okay.
Yeah, so right.
Down here?
Yeah, right there. Right click on that. Okay, so I just want to find the location of the file. That way we can allow it through. So it looks like it's not there. So go into your settings. Start.
Arduino IDE. This one.
Right click and let's go and find
app settings.
Yep.
It's an app.
Okay.
That's the problem. It's an app.
Okay. Defaults. Just want to see how we can get the security settings. Or maybe we should download the full IDE from the website.
Maybe, but I'm also thinking.
Yeah.
This is the app, right? Windows. I'm gonna switch to Windows so y'all can see what the heck is going on. So I'm inside of my Arduino IDE thing here, right? And this is a Windows app, okay? And the thing that's really getting my goat is that I installed this Arduino a long time ago from the website, and it was good. But then Windows was like, "Hey, come install the Arduino from the Windows Store.
It's better.
Come install it, and it's better." And it was not better. It was worse. And now I'm ticked off because
I think I have to install the real.
I'm gonna have to reinstall all my packages again because I keep installing all these crazy packages for like ESP32, ESP, all these different boards that I need to support for my programmers and stuff like that, whatever. And you end up having to take these libraries and like I'm gonna have to make like a repository or something like that filled with all the different libraries I use.
You can put it in your user folder. That's the best place. So
because it seems like I keep losing them every time.
Well, that's because you let Arduino do its default. When you should really create your own folder, your own documents folder.
Yeah, probably.
Yeah. Okay, I think let's uninstall this. Let's actually get the Arduino.
Okay, so
we can actually
let's uninstall it.
We can actually try the online Arduino IDE.
Okay.
Because this one doesn't require very much anyway, so rather than going through that, subjecting people to us to installing a whole bunch of stuff, we'll just go to the online IDE, which is actually quite nice. So open up Chrome. So we want to share a Chrome window and
build stream, this one.
Yeah.
So we're just gonna go in Chrome?
Yeah. Okay, new tab.
Yeah.
And we want to actually go type in Arduino ID. And let's see here, there is online actually.
Is it the first one?
Yeah.
This one here?
Yeah, that's but there's also online version as well. Oh, code online, right there, what about there? Right there.
Accept all. This one?
Yeah. So we kind of show this for people; they can see what's happening.
So like I said, I'll switch over to I guess.
Oh, but you need to sign.
Should we use the Windows one?
Yeah.
Oh, we have to sign into it.
But you should probably it uses.
I should sign in before I have to sign into. Okay, you can just sign with Google.
Yeah.
So here, yeah, that's fine.
Yeah.
Click here. Well, people will see my email address. Oh no. People will be emailing me.
Do you want the newsletter?
Oh, no.
No. You just need to. Yeah, that should be fine.
They gave me a bunch of checkboxes, okay?
Yeah, I think you have to install an extension.
No, I didn't leak my email because I didn't put it onto to screen cap mode. But if I did, I would have leaked my email, which would have been interesting, wouldn't it? Someone could email me on my personal email address. It's not like it's like secret information or anything, but still.
Okay, there we go. So let's actually copy and paste the sketch in here.
Yes, this one here. Okay, should we now screen share it?
Yeah.
Now that we've gotten past the part where we accidentally leak our freaking email. Okay, here we go. We'll go Windows here, and I guess we'll use webcam 2. I guess we don't need that one. We actually what we want is add.
Just add the window.
The Droid cam.
Yeah.
Well, that's all we want. It's just
yeah.
this because then people can see what we're what we're talking about. Okay, so now we're gonna go over here. I'm gonna take this, put it in here. Perfect.
Yeah.
And we'll save it as. How do we save here?
You can go name it something, I believe, over there, or
here maybe.
Let's see if that's
rename sketch. Hall sensor. Okay. So now can I upload it? How do I upload it? Same way.
Verify and
verify.
Yeah. And you have to check the library. Okay, so verify that. So then I believe
select other board and port.
Yep.
Demilanov on @mega. What? Oh, that's kind of cool. It calls it a flavor. It calls it a flavor. The type of board you're using is a flavor. I like that. It's kind of spicy. Okay, here we go.
Okay, and
verify. Busy.
Thing has to know which port.
Done verified.
Okay.
How do we choose the port?
Yeah. So recall preferences over here. And no, it's fine. So I think
Sephora old.
Yep. So recall what it is that you have to give it permission to access the USB ports.
Okay, how to do that?
So go to, if you're in Chrome, go up to the lock symbol.
This one?
Yeah, right there. Click on that, and go down to site settings. And you actually they do allow you for your web browser to access USB ports nowadays. So go down below USB devices, and then you want to just allow or ask, I guess. Now it's already set to ask.
It's already set to ask.
And serial ports, that's already set to ask. Okay, that's fine. Let's look it up here.
Huh. I'm gonna open up Twitch and double check. Say hi to Sephora. Oh god. I gotta mute this before I hear myself. Sorry, I hate hearing my own voice, so panicked a little bit when I thought I was gonna hear my own voice. A key. So display info.
Okay, we have to install a plugin.
Really?
Yeah.
Okay.
So
how do we do that?
Let me look it up here.
Reload?
So, yeah, reload.
Loading Arduino Cloud. To upload a sketch via USB port, make sure the agent is installed and running on this computer.
Double check here. Oh yeah, install the agent. There. Yep, down for Win64.
And do our best not to leak sensitive information.
Check public network too. Okay, so let's go back to our IT environment.
So Ferrer says, "Nah, I feel the same way. I sound like an 8-year-old kid." Yeah, I relate. I relate. Install some drivers. Needed to use Arduino / Genuino boards. Do you want to continue? Yes. I'm happy that I'm not the only one who just like legitimately panicked. I'm like, oh god, I gotta mute myself before I hear my voice coming through again. I think it's just, I don't know if maybe my voice just sounds normal to people, or maybe it's just hearing my own voice is weird. I'm overthinking this. Okay.
So actually we can close this because this is just settings. It has nothing to do with what we're doing right now. Next, what happens? Go to web editor.
Cool. Hopefully it's working now. Let me double check and see if it's running in the tray. Yes.
And upload button works.
Ooh, upload.
Let's see if it uploads.
Upload.
Okay. Oh, did we check the board? Select the board. Maybe the port.
How do we choose the port?
I think it. Did it find it? Try it. Let's try uploading again. Maybe that's in the tray. Hit the upload button again.
There's got a line here that's like disconnected here.
Okay, select.
See, it's got an
port.
X. Select board.
Oh, there's the top one, native USB port. Maybe do? No, actually no. I'm trying to think of which one it is. Demlova at Mega, that should be fine.
Let's try it.
Mm-hmm.
No.
No. Okay.
Let's try 328. Maybe it's the 328.
Those little dots in the edge. Does it do anything? Nope.
Do you mind to open up touch so I can see if?
Yeah. So everyone else seeing. So this is what everyone else seeing right now.
Oh, okay, good.
Okay. Yeah. Okay. Let me double check here.
I'm so confused.
Mm-hmm.
Verifying hall sensor.
Mm-hmm. Oh, okay.
It's been verified.
It's only okay. Fortunately,
we probably have to restart or something, right?
No. The reason is that we have to go because this is only for the official Demilo. But this is this is official, right?
Yeah, this is Arduino Demilo. But the only thing is that we hacked ours last time to become an FT232 RL.
Oh, okay.
So maybe we have to use a different device.
If you have to manually select it here, so then we have to go, I think, to the bottom. We hacked it. Yeah, so what then you go to drop down selecting device, select the board, and you have to go down to the bottom because then you have to manually choose device. Does it have it?
We hacked our board last time, guys.
Do you have another one that's...
I knew it was going to come back to it. Yeah, I'm just going to go to a different board, okay?
A generic USB? I think there's something that's a generic.
Native USB port and programming port. Arduino Due.
Mm-hmm. Can you go down? I think I saw something about generic device. Farther down, down. They do support a whole bunch of devices. No, that's generic. Okay, no.
No. Okay, well, the closest thing they have is a Demilanov.
Sure.
Plus the Atmega 168 for the flavor.
Mm-hmm.
I'm really happy they call it the flavor for some reason. Error uploading. Check if the selected board is available.
Mm-hmm.
It looks available.
Mm-hmm.
Does it look available to you guys? It looks available to me.
Can we select a different serial port? Can you go to serial monitor? Go to monitor.
Monitor?
Yeah. Can we choose? Nope, can't
serial port unavailable.
Okay. Let's actually check the
preferences.
Device manager. Let's see if it shows up.
Device.
Oh, okay. Yeah, it's not recognizing it.
This one?
Yeah. So that's why. Right click and let's update driver. Search automatically.
Uninstall?
Okay. Oh, okay. Uninstall. Okay, so.
What's this one?
That, I think that we had an issue with that before. There's something inside your computer that they can recognize.
Okay, yeah.
I think we're finding that. But, okay.
Okay, so unplug it and replug it?
Yeah. You might hit install.
Yeah, it seems like it's still trying to do UART
okay, setting
thing.
it up. So maybe it's trying to find a driver for it. So we might have, I think in the past we had to install.
We reinstalled this thing. I can't remember what we were trying to. Oh, we were trying to reprogram this thing as a USB keyboard.
Yeah, that may be why.
I think that's what fucked it up.
Okay.
Okay, so sorry guys, oopsies, swore there. Okay, I'm gonna go get a new board.
Wait a second, let's see if I have a nano around it or not.
I probably have one downstairs. If not, hopefully you have one.
I have one, maybe. I do.
Arduino Uno. It's a genuino Uno. Hello guys, this is my box. It's an Arduino box. I guess we should change the build one so that we're going back to build stream for a moment. So here's the thing here.
Okay, I don't think you're in the build video. Oh, there it is now.
So this is an Arduino Uno, genuino, and hopefully it will just work now.
Oh, it's saying up as an Arduino
Uno. Yes,
that's
good.
That's why, because it's trying to be...
it's trying to be a USB keyboard. Oh man, I don't even know how we would fix that even.
Have to redo the firmware.
Completely reboot it.
Okay,
bootload it.
Actually, now let's go back to the...
Here?
Yeah.
And
Uno's found it.
Oh wow.
Yeah.
So we need to click on that now. Yeah. Okay, so wait, let's go back to Windows now so y'all can see what we're doing. So we've got the COM support 6 is showing up now. Click on that. And we're going to upload, and hopefully it will just work. Uploading. And reading on chip flash data. AVR dude, done.
Okay.
Totally radical, dude.
Now I have to wire it back in again.
Yeah, now I gotta unplug this and wire it back in. AVR dude. AVR dude makes me laugh. It's just funny that it's called AVR dude. Okay, wait, here we go.
Okay, our pinouts again.
Yeah, that's gonna go there, and this was pin 3, right? I think that's the way it was.
Yep.
Correct me if I'm wrong. Hopefully this will just work out.
Oh, we should go back to the display of the you're in the program.
We don't need a serial monitor.
Yeah.
Remember, because it should just. Yeah. If it works now. Oh yeah, that's not working.
Right. Give me a second. This is magnetic.
What is? Oh, it worked. That worked.
There.
That's actually working.
Actually, yeah. So
here,
turn the camera around.
So give me a second. We actually have. We can get a magnet.
Yeah.
Crikey! Okay. I feel like I should go grab one of those magnetic rings now.
All right. Oh yes.
You can test it with the magic side. Because we only have one. We have one viewer, and it's a magician. So
yeah. Okay.
Okay. I didn't actually grab a PK ring, but
let's move things around so people can see.
This is almost as good.
Central.
Why does Saphira say well done? Oh, because we got it working? Yeah, I'm proud of myself too. Okay, so here we go. So now we've got the light there. Can you see the light? So if I take this bunch of magnets, this is a bunch of magnets in a bag, and I touch the hall sensor here, y'all can see.
Oh, you just want to flip it around. That way people can see. Yeah, there it is.
But it actually lights a little light inside there. That's crazy.
Yeah, you don't even have to touch it, just get close enough.
Yeah.
Yeah, there.
Right about there.
About a centimeter distance, yeah. Looks like orientation matters too.
Yeah, it does, because the back of it, this side does.
Yeah.
Yeah. Seems like the orientation does matter, because this side doesn't do anything.
I think there's no magnetic field in that direction, because these are little disc ones, so the magnetic field's...
I mean, yeah, that's what I'm guessing, is that they're all stuck together, and they're all creating one.
Actually, pull one out, and let's see if we can trigger it more effectively.
This is like a whole bunch of little guys, because in Magic, these little magnets are so useful.
Hold in place.
Tiny little magnets like this. See, there's a whole bunch of them. These are not the kind of ones that you want to have around Kiki, though. Kiki will eat these magnets. And then magnets are bad.
Oh, there it is.
On the other side?
Yeah.
Oh, the other side works too.
Yeah.
That's actually sick, though.
So I think does it work planar? So was it face-wise?
It seems to work like that, too.
Yeah.
That's sick, though. There we go.
There we go.
That's actually awesome. Should we do another sensor?
Okay, that's sensor number 1.
This is super sick, though. I wonder what we could do with this. Before we move on to the next one, let's discuss what we can use it with. So now we have this little sensor here. I wonder if we can put this little sensor inside of some sort of
a box and then relay?
A box or something else where it's like it just needs to hide the electronics really, and then you can use that as like a hidden switch or something. Heck, you could even use that as like a hidden switch in like a escape room or something.
Yeah, or if you put that one of those back to the tip of a magic wand or something.
Oh yeah, you could do that, and then it's like then you you go you wave the magic wand and then it triggers it, right? Yeah, that would actually be pretty cool. My only concern is that I feel like with a magic wand, it'd be easy to accidentally miss the sweet spot. Yeah. The sweet spot seems to be like right here. So imagine there's like a little, about that big. That's the sweet spot around the
I think
device.
Actually it's triggering now.
Oh, it is.
Or something or something disconnected.
Oh, I think that might have short circuited.
Maybe shorted. Oh, I think we have to re-plug it back in. Oh, no, it's working again.
No, it's still good.
I made Arduino flaked out. Is the light going on Arduino?
No, I think I accidentally just zapped it by accident with the freaking battery because I'm a genius, of course.
yeah, the light is going on the Arduino itself.
Yeah.
Yeah, there it is.
The LED built-in down here. It's right there. That light there. Can you guys see that tiny little light there? That little light there is the one that's going on and on. That detects the sensor.
Oh, that light can also hook that digital wire to something else and trigger a...
Yeah, you could totally have it activate like a door or something. Or if you were doing a magic trick, you know what we should do with the magic trick is that imagine this: if you have some sort of compartment, you can show like like the device or cabinet like completely open. Nobody can tell like that there's not anything inside. Then when you're ready to activate the illusion, you use the Hall sensor, and then produce your whatever your motorcycle or whatever. But you can totally use a Hall sensor here as a secret switch. That's
a magnet something, or maybe actually would be great for an escape room because some kind of artifact you have to place on the altar in the right way.
Yeah, and then just have a magnet in the bottom, right? But this is sweet. This is awesome. I am definitely thinking of some projects to use with this Hall sensor now. Okay, let's do one more.
Okay. So back in the bag it goes.
Yep.
We put it aside.
Okay.
So we will shake it
up, and I'll close my eyes.
The pack's so tight, it's not shake.
It doesn't shake. There's gonna be like a bunch of them here, and I'll pull one out.
Okay, there we go.
No feeling. Here we go.
Okay, let's see what that is. So,
what is it? This is crazy. This is a relay module.
Power.
Oh my gosh.
You need to get a battery pack out now.
Yeah. Actually do. we can run this off of the relay. So this is the little gearbox that we made last time. We're gonna run that guy off of the relay
now because previously we couldn't control. We just ran off the battery, but now we can use the relay to control this now.
Yeah. And okay, so what's the point of a relay? Well, from what I understand, a relay allows us to control electricity kind of like a transistor, where you use a smaller...
it's like a light switch in miniature. That's what it pretty well
Yeah,
is.
it's like a light switch in miniature.
Mm-hmm.
But it allows you to control a larger voltage with a smaller voltage. So in this case, we're going to be using the Arduino to control this relay, and the relay is going to be what controls our gearbox.
This gearbox motor, there's a little DC motor in here, but with things we can't power this directly off an Arduino. The reason why? Well, this requires a couple, maybe half an amp to a whole amp of current. And that Arduino, maybe 20 to 50 milliamps at the most before it blows, so we can't hook up directly. However, this thing, the relay, essentially is just literally like your light switch in a wall. There's a physical contact inside that actually will close and open depending on a switch being pushed back and forth. But how does it push back and forth? There's actually a little magnetic coil inside. So the Arduino itself is able to provide just enough current to power a little magnetic coil, pulls the switch to one direction, and it switches physically on. So that's how relays work.
Yeah. So the one thing about this is that this little relay here can actually support, oh my god,
how many amps? How many volts?
10 amps, 250 volts AC.
Whoa.
That is crazy.
That means you can power actually like a blender or something.
Yeah, you can power a blender off of that.
Or
and
microwave. Actually,
that's insane.
Yeah, 200 volts at 10 amps. That's 2,000 watts.
That's insane, though.
Yeah, it can do 2,000 watts.
I don't know. I feel like the thing would melt or something. I don't know.
Well, as long as the conductors are fat enough.
Like the wires would melt before this thing does. Yeah. Let's just say that.
If you have fat enough wires and low enough resistance, it will work. You know, don't want to use thin wires like this at that much voltage, but something like maybe.
So I'm taking a look over here. We have 3 pins coming off of the relay here.
Yeah.
And our relay here is going to enable us to control a much larger voltage, even more than we would ever need even for this little gearbox.
Yeah, we can control wall current with that thing.
This thing is very powerful. It also has a little diode in there.
That's a kickback, because when you open up a relay, because it hooks up to wall current, you disconnect it, you're going to get a spark, and the diode shunts it to ground safely.
Okay.
Yeah.
Okay. I also see here on the back that the 3 pins have 2 words or 2 things that are written in between the pins. Between 2 of the pins is NC, and 2 of the pins is on. So I'm guessing that these ones are normally on,
normally closed,
and these ones are
normally closed.
Oh,
yeah.
okay.
Normally closed. So that means it's a 2-pole switch.
I would think that it would say NC/NO, wouldn't it?
Normally open.
But right now it says NC and on.
Oh, okay. See here, so we should probably look up specs.
Yes. That's a solid plan.
Let's go back to Key Studio, check the specs. All else fails in electronics, always read the spec sheet. You do not test it by licking,
yeah.
It tastes like 5 volts.
It tastes like 5 volts.
No, you don't do that, you look at the spec sheet.
Yeah. Here we go.
Do you test voltage by touching both sides? No, you don't do that either. Spec sheets.
Okay, Project 33, single relay.
Okay.
Okay, this single relay module can be used in interactive projects. This module uses Songle 5-volt high-quality relay. It can be used to control lighting, electrical, and other equipment. This modular design makes it easy to expand with Arduino board. The relay output is by a light-emitting diode. It can be controlled through a digital I/O port, such as solenoid valves, lamps, motors, and other high-current or high-voltage devices. Specifications: digital, rated current 10 amps. So we know this stuff here.
It looks like normally open is 10 amps, and the normally closed is can do only 5 amps. You notice that the specification rated current.
Oh, really?
Yeah.
Okay. So the other one that says on is actually normally open, even though it says no NC and then on. Contact action time 10 milliseconds.
That's because it's physical. There's an actual physical switch moving around inside. Yeah, in terms of switching voltage, you can do 150 volts AC, but only 24 volts DC. But it rated loads. Again, 8 amps, 150 volts, so that means, actually no, that's about a kilowatt.
It's quite a bit.
Yeah. A little bit less of it's DC. It's 250 watts.
Yeah.
Mm-hmm.
First, you need to prepare the following parts before connection. Arduino Uno board. Got the board?
Oh, we need to use other stuff.
Relay module.
Is this thing here?
There you go. LED module.
Pull it out here. It's going to be a combo project this time.
Okay, and we also got a breadboard.
Mm-hmm.
USB cable. Jumper wire times 9.
Mm-hmm. Yes, we have our jumper wires.
Yay!
Yay!
Although we need the male ones, I think.
Okay, yeah. It's
yeah, these ones are good.
No. Okay. Let me just find the other LED one. Drop it down. What LED, or just say any LED? That line. Okay. You might be the white.
Yeah, I think it's the white LED.
Okay. Mm-hmm. Yeah, not the RGB. Although are they using RGB? No, they're not. I guess
they're using the white LED.
Yeah, what is that?
I think that's the one they're using because that looks like the module that they have there.
Yeah. Just there weren't any other ones, were there? Let's see what's the other ones. Okay, we'll assume that one. Oh, is this it? No, this is a different one. This is another. No, this is an iron emitter. I think the label came off that one.
Ah. I'll make another one.
Yeah.
But I think this is the one that we want us to use is this LED one.
Yeah. Okay, we'll go over that one.
So give me a second. I'm just going to hook it up in the way that they suggested here. Only thing is that the way they suggest is really dumb. Yeah, I'm not going to do it the way they suggest. Fuck that. That's insane.
So maybe we'll just use the built-in LED or something.
I'm gonna.
Sure.
Well, we could use the built-in LED. No, wait, we don't want to use that built-in LED. We really want to control this thing.
Okay.
So this thing is going to become the outputs for our thingy.
Yeah. So we need.
We don't really need to use this thing.
Pack as well too. We're going to do that. So we're going to.
Oh right, because then we need to feed the electricity into the relay.
Another power supply.
Give me a second. Let me think here. Screw it. We'll run the LED off of it. We'll run the LED off of it because that's the easiest. We'll just follow their thing here, and then
later on we'll improvise.
We will improvise later. Can I get at the jumpers in there?
Oh, sure.
Thank you very much. Oh, look at this. We have a bunch of JST connectors. Can you put off the side? That should go in there with the drone stuff.
Oh, yeah.
Okay, that's there. And that's gonna be ground. So in this case, I'm using yellow for signal. That should be okay. Yellow goes to signal. This is going to be... Ooh, that's kind of crazy. Look at this one. This one kind of melted a bit, Alan.
Oh, did it...
Look at this. Look at this. That jumper. It looked like it overheated.
Oh, it did.
I don't know if we want to use that one.
It should be fine. It's a plastic. It's a mechanical connection anyway, so the electrical part should be fine.
Okay. Let me put away these magnets before they get lost.
Yeah. Should put it back in here, or...
That's okay. So it'll just go inside the baggie because we might need to use it. Oh wait, no, we don't. We're done with the Hall sensor now.
Yeah.
It's okay. Whatever. Oh, this is the IR transmitter. This one needs the label put back on it. Can you put that one off to the side, Alan? Yeah. Thank you.
Sure.
So white LED. Now use the voltage. Is this one? Yeah. Okay. And so this one's gonna go to. Oh, that's so weird because this LED here has. Oh, it's not an LED.
Yeah, okay, what is it?
It's more than an LED.
It's a white LED?
It's a LED on a transistor or something, Alan.
Oh, okay.
So let's take a look at the module here, because actually we should take a look.
I think it's the high power LED. So it might be ultra bright, which means it requires more.
We'll come back to this in just a second. I just got to scroll up for that. White LED, the first project.
Can we get more specs on it?
Doesn't see that much specs.
Mm-hmm.
That's it? That's it? Yeah, that's it.
Yeah.
Oh well.
Mm-hmm.
So no. I was hoping to get more information.
Mm-hmm. Well, I guess it's a switch LED, so you provide it power and you have a.
It has a voltage, ground, and a signal wire. That's the thing that immediately threw me off. I'm like, this is an LED. It shouldn't have more than.
But in this case, they actually are switching it using a transistor. Therefore, your power source doesn't have to be the same as what you're controlling with.
Yeah.
So you're not limited.
Much as I don't like that, I'm going to keep that in there. Okay, now this guy here is going to have a yellow on signal, or actually we'll do yellow on voltage, white on signal, blue on ground. Can I watch it print?
And that was talking about printing something else, or
what were we printing?
Mm-hmm. I think we're talking about printing something for the Stream Deck or something, or I'm trying to think.
Oh yeah, I think so.
Yeah, I think we'll do that at some point. Where we redesign the cover, we'll have it running in the background or something.
Yeah, that's what we're gonna do next time. Is when we make the Stream Deck completely finished. We're going to print up the a new case for it and make it all completely new. So this guys are going to go. So these two go into signal and voltage.
Okay, so
no, that doesn't look like signal and voltage. Where the heck is it going? We use the LED.
Okay.
For relay module, Uno, blah 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 blah. Just go there. Okay, wait. I'm gonna open up this tab here. Okay, so positive and negative. So voltage and ground go to the thing. The weird thing about this is that they actually have it kind of backwards-ish. Yeah, their wire's not the same as mine, but the positive and ground, and they go to positive and ground. So this is gonna go to ground, and this should go to positive. Okay, and then the signal of this is going to go to pin 8 of the Arduino. Okay, and pin 13 is going to go to all the way over there. I guess so. Oh, I see why.
Oh, that's the.
That's the control. That's the control of that one.
Yeah,
Now, here's the crazy thing about that one. Is that how are we going to use these jumpers on that? Alan?
Okay, I'm looking at the relay. Oh, I see. They're using this as just a switch. That's what they're actually not using as power. So this is going to be indirectly switched through the relay part.
That's what I can see. I can see it there. That's kind of weird.
Yeah, I think. Yeah, normally, okay. Well, this is because we're not really powering anything real, so to speak. What they're trying to illustrate to this is that you can actually, it's like two switches in a row. That if you have one switch open, the second switch needs to be open for the signal to go through. That's why I think they're trying to illustrate that the switch is actually working.
Yeah.
Because pin 13, we're going to digitally switch that, but it's not going to be able to get from that orange side to the purple side unless it's been switched on.
Yeah.
Yeah, so that's what trying to illustrate. And then, of course, the signal then travels through the signal, which then turns to LED. So it's like two switches in a row.
Yeah.
So that's the kind of illustration, the illustrative purpose that they're trying to have here.
Yeah, that makes sense. Okay, so how are we going to use it?
Okay.
I can understand how they're supposed to use it
okay.
now. We want to try and use it to run our relay, right?
So maybe actually we'll try to, if we can get a battery pack and...
I can grab a battery pack from downstairs. In fact, last time it ran really well off of just some AA battery stuff.
Maybe we'll just do you have
so
a
why don't we do
AA pack?
Why don't we 3-print one? Because I have... Oh, you know what? Actually, we do have AA battery packs. Maybe we'll just grab one.
Yeah.
Let's grab one.
Let's grab one of those.
Sorry.
Yeah.
Okay, I will be right back. I'm going to grab that. Got it. Okay, now that I got it, I need to fill it up with batteries. So excuse me. I'm gonna grab some batteries from over here. And then I'm probably gonna make myself a stack.
First, we'll just check it out. Just make sure it works in this first. I'll put some pins on that in the future. Put a piece of tape on here, that way they can see something around.
Sure, do you have a piece of tape anymore?
Do you have a piece of duct tape? Just put a piece on it.
Where'd the duct tape go?
Where'd it go to? Here.
Oh, it's over there.
So if you want to hook it into the normally open end, because when we close, then we'll actually.
Hey, so Pharaoh, you know what we'll do is once the build stream is over, I'll just let it. We'll just stream our 3D prints for the night, because 3D printing is so beautiful and amazing. But when you do a long print, well,
there we go with a flag that hopefully is visible. Okay, so you can hold it up to the camera. You see it here. Let me see.
What was I going to try to say? When it's a long print, it looks like it's printing the same thing for a long time. Oh shoot! I just saw a little sparky spark. That's a good sign, right, guys?
Oh, we're just hooking it to battery, so it should be fine. It's just induction to battery.
Woo!
This motor works, but now we want to computer control this. Otherwise, we don't want to be all the time.
Yeah. So now what we got to do is we got to hook this up so it's being controlled here. So this is on pin 8 here, and we actually want it to do is we want it to voltage and ground from this, right?
Yeah. So the voltage and ground on this side.
So I'm going to plug this guy in here.
Yeah.
Like that. And then, can I have one more? I need a male-to-male jumper. Here, that's a purple one. I like purple. Let Magro know that I used a purple jumper in his honor. Because he likes purple.
Okay, so this is actually going on this end, so we just have to put this in series.
So can I just put that in there?
No, actually we don't, because we want this to be power after relay. The whole point is you can separate your power supplies with a relay.
Yeah.
One half is digital, and the other half is going to be purely on, because this is a physical switch. Everything's isolated, which is how we can hook up to 120 volts or 200 volts.
Oh, okay.
On this side.
So wait. So this side here is actually the Arduino power?
Yeah, Arduino power. So purely Arduino that side.
So should I plug this into the 5 volts over here?
Yeah. So actually we don't even need this here at all.
Yeah. And then this over here on this side is literally going to complete the circuit, right?
So let me see if I recall here. So we actually have one end that's going to be the middle ground. Let's go back. Let's get to the documentation.
Yes. Not this one. This one.
Yep, there we go. So hopefully they can give us a circuit diagram on this thing. So normally, the relay is that you have one end is the power source, and then you have a common ground.
But one side here is normally open, and one side is normally closed.
Yeah. And then
so this side over here is if we wanted it to be a switch, it would be over here on this side.
Okay.
This would be the switch because this is normally open, and when the relay is closed, this becomes closed.
Also have to provide the power to this as well too. So what happens? You have to put this in series. And so do we have? We need. Let me get some. Let me see if I have any alligator clips.
Do you have a little screwdriver?
I do. Yeah, we need alligator clips because what happens is because it's a physical circuit. Essentially, we have a series circuit.
Can't I just shove it in there like that?
Yeah, like that. Yeah.
And screw it down.
Yeah, and I want to hook up in series with the motor. So what it is, it's going to go in loop like this.
Yeah, like that, right?
Yeah, like that.
And then when it closes, it'll
power it on. Yeah.
Yeah.
So we just need to finish the loop. So
do you have a flathead?
Actually, what we do is we can actually use these. So we need female to. So we can probably do with what we have.
What do you mean?
Because we just have to essentially make a loop. We can probably plug this into a female plug.
Oh, okay. So then that can just plugs right in here.
Yeah.
Hold up.
Yeah.
Hold up.
Yeah.
I just gotta twist this one. That's all good.
Yeah, because all we do is just complete the loop. That's all we have to do.
Hey, Safira, are you still here? Or did you go off to play the Warzone yet?
Yeah, you may have. Who's on?
I think it might just be us. That's okay.
Yeah, just us and Margot or something.
maybe we have a viewer. Shout outs to a possible viewer.
Yeah.
If I go check, I can actually see who's there.
Yeah.
Same time, sometimes people like to come into the stream and they don't like to be shouted at and pointed out and be like, "Hi there, you're the only viewer on the channel."
Yes, you right there.
You right there and then call them by the name. Yeah, that's not cool. That's not cool.
Just a complete loop. Okay.
Okay.
And here's my screwdriver. Let me switch to not that bit.
Not that one. Okay, cool. Oh, this is exciting. So what's the point of having this side connected to the voltage and ground? It needs to be that way, right?
Because it needs to be powered because there's a digital component. There's actually on this side, there's actually either a transistor or digital switch on that side, which goes in here.
Okay.
Yeah. And that magnetically pulls that switch open or close. On this side, we turn way more current. So get that bit there. That should work.
How come it's not going anymore?
Yeah,
the heck?
I think it's kind of a little bit flaky just because it's we need better contacts.
Well, that's weird. I jammed a bit.
No, jammed. Okay, try it again. Oh yeah, it just might have
jammed.
Okay, there we go. We know it's good. Now we can actually get this in. So
okay,
here's the driver. Oh. Comes off all the time. There we go.
So this is really cool because we can eventually use this kind of relay to power a robot.
Yeah. Or a lawnmower or something.
Or a lawnmower or something, because this is actually crazy amount of juice, right? I guess when we're using our robot, we can probably use like MOSFETs because we'll just be driving like one motor at a time, right?
But this can handle way more current. No, this can actually handle AC as well too.
Yeah, we could power a blender like you were saying.
Yeah.
Or you know what we were saying? That remember that huge industrial fan that Leroy gave us?
Oh yeah,
we can use that control that thing.
Yeah.
Which is gonna that's gonna be a scary episode for you guys because that's the day we're gonna have to do big man things and use it my electronic skill to power something that could kill me. Hopefully, is that in? Hopefully that's in. Let's give it another quick another. Oh. Okay, I think that's good.
Okay.
Yeah, that seems
okay.
good.
So then we think what program we want to do. So I think.
So we can just use their program.
Yeah. This turned off in 2 seconds and on. Yeah, this will work.
Okay, we'll just use that, and we'll also use the website.
Yeah.
And we'll just copy that.
Save it under a new name.
Yes.
Do not save as.
Rename as.
Actually, no. This will overwrite this one. Or do you want to? I guess it doesn't matter. Yeah.
New sketch. How do we do save?
Save as.
Save as. This is going to be single relay. Because that's what it's called in the thingy.
Okay, we'll upload it.
Upload. Oh,
I have to plug it in.
Anything heating up? No, everything good. Okay, here we go.
All right, uploading. Folding this up. Oh, something happened.
It's getting stuck.
Yeah.
That's sick.
Yeah, we're having issues with the gears and stuff. I think if we had...
I think if we had more juice, it would probably be fine.
If we had something like that, actually...
Should we use 18650?
We could do that.
Okay. Okay.
Right.
Let's go grab a single 18650 and plug it in.
Okay, that'll be 4.5 volts. This is only... This is 3.5, but it's kind of doesn't put up much amperage.
I feel like the 18650 is gonna kill the last time. Remember last time? Yeah. Oh well. If it dies, it dies. Oh boy. This is going to be exciting. This should be exciting.
So put some white stars that way this is a little more visible.
Oh gosh. What am I doing right now? Let's...
We should just hold it in place.
Maybe?
Yeah.
Maybe I should just hold it in place? Although maybe I can re-screw this end in.
Oh, well, yeah. You can go directly.
Okay.
Okay.
And then this side, I guess...
Just hold it in place.
Just hold it in place.
Yeah. And just have to...
Plug it in?
Plug it in.
Oh god.
Code should already be there. Is it? Oh, something happened.
It's going, it's just jammed.
Yeah.
It's totally jammed. Okay, that should do it.
Okay. Sometimes issues.
Turning on.
Okay,
Feels like it's jammed up inside.
yes, jammed.
It's jammed again. Why is it jamming?
Okay, there we go. So I think it's unjammed. Ooh.
Yeah, that blew up. But that actually, you know what? That's fine.
That's okay.
So, mission success. I'm gonna call that mission success, guys. It blew up, but it blew up. That was what we were trying to do, and I predicted it, so I'm gonna call that a win.
Right out of the way.
Yeah, actually, let's pop it out of the case thing.
Save it. Yeah. But it's a proof of principle. That's the main thing.
Yeah.
We know it works. We control more power than we know what to do with.
Oh my god, we actually did though.
We can control destructive levels of power now.
Yay! Now we just need to power our frickin' laser.
Yeah.
It's sharks with frickin' laser beams on their head. That was actually quite epic. So this component is super duper useful.
Yep.
And now that kind of makes me want to buy more relays.
Mm-hmm.
Because relays seem useful as heck. Oh, wait, where's the little
bag.
baggie?
Mm-hmm.
Where's the little baggie? There's a baggie. Cool. Well, that was our stream today.
Yeah.
We're just going to be doing a little debrief now.
Mm-hmm.
And talk about some of the cool stuff we learned today.
Mm-hmm.
So what the heck did we learn? We learned some cool stuff with the Hall sensor. The Hall sensor is quite interesting. It seems to be able to detect magnetic fields like an area around it. So I'm betting that if I get other Hall sensors, that we could probably do some really cool stuff, especially with magnets. I heard that some of the other Hall sensors you can get, like more expensive ones at least, can also detect like which pole is closest towards it. So I'd love to see ones that are kind of like that, because they seem like a really neat sensor. The other sensor that we did was the relay, and the relay is pretty astounding because just the sheer amount of voltage or even current that it can supply.
Yeah, looks like you can do, if you on AC, you can do so like maybe about 2 kilowatts?
Something like that, yeah.
Yeah, but DC a little more limited, maybe 200 watts at the most, but that's still a lot more power than...
That's almost more power than we need. it provided enough power to blow up our little gearbox.
Yeah.
Which, you know what?
Uh-huh.
That is completely fine, because the gearbox didn't spin that fast to begin with anyways.
I think it needs to be refixed anyways, because again, it
well, yeah, you were saying that we could 3D print it again,
yeah,
a little tighter tolerance,
yeah,
and that's going to make it so that it doesn't hopefully break.
Mm-hmm.
Right, Alan?
Seems to be better now.
Oh, it fixed itself.
Yeah. Mm-hmm. It was jamming previously.
Should we try it again?
Yeah. Let's hook up the 3 volt.
Yeah, let's
hook up the triple A's. Hopefully it'll just work.
Because I'm worried that if we hook it up to the other one again, it'll just blow up.
Mm-hmm.
I think the problem with the relay when it was doing that was that it was starting and stopping.
Yeah.
It seems to be okay if we just leave it on, but when it starts and stops, it gets upset.
I know what happened. It came off.
That part came off.
Yeah. Spun to. Okay, yeah.
The spindle.
Yeah, spindle. Okay, but that's fixable. The
Yeah.
motor itself is working.
That's such a cool little device, though, the gearboxes. I honestly want to make a robot out of those gearboxes now.
You can now.
I think that we can definitely take advantage of the fact that it uses such a low voltage in order to create a lot of mechanical movement.
Mm-hmm.
I wonder how we can take full advantage of that now.
We use it as a wheeled robot, something.
Yeah, a little tank.
Little tank or something like that.
That'd be cool.
We need to use a H bridge in order to make it go backwards and forward, but
because I was saying that.
We should an H bridge.
Yes.
An H bridge demo.
So next week, that's what we'll do, guys. Next week we'll do a little H bridge,
which means you can make current go one way, the other, which means you can make motors go one way, the other.
Yes, indeed.
Mm-hmm.
And that way we'll be able to try our robot out, and maybe what we'll try and do is we'll try and get this gearbox running backwards and forwards as well.
Yeah.
Anyways, guys, if you guys like that, please like and subscribe. If you guys are on Twitch, please subscribe to my channel. And yeah, thank you guys so much for tuning in tonight.
Yeah, hope you enjoyed it.
I hope you guys enjoyed it. And I'll see you guys next time.
Have
Take
a
care,
good night.
everyone.
Bye.
Bye.